Or you can just call me Steve. This is a joint work with my former students who graduated last year and also with NTU, National Taiwan University, and UC Davis. So nowadays, online learning platforms have been prevalent sources of self-paced learning to people. However, the lack of peer accompaniment and social interaction can cause negative impact to learners' motivation and learning experiences. So there are some studies try to enhance social interaction. For example, they include they added some additional communication channels like chat rooms and discussion forum. Nevertheless, these do not solve the problem effectively due to the low participation of learning in these communication channels. And also, there are some studies on virtual classroom in Second Life or VR learning with co-learners. They aim to improve the participation and immersion of learners. And however, these systems require the instructor and online learners to be online at the same time. And this conflicts the goal of self-paced learning. So to solve this problem, Li and all proposed an interesting idea to stimulate synchronized communication by asynchronous participation. So they recorded previous learners' comments in the same class, which are attached to a specific time point of the video. And then when a new learner watches the same video, those comments are displayed according to the playing time of the video. So for those of you who know that Nico is kind of applied Nico to MOOCs. And in this way, individual learners taking the same class asynchronously could still feel learning with others, even though learners are not online at the same time. So inspired by this previous work, we propose a notion of virtual classmates, which are simulated based on previous learners' time anchor comments. So this problem could be formulated as a mapping problem because we do have a constraint that we couldn't allow too many learners in the virtual classroom. So we will need to a mapping between the large number of real learners to a limited number of virtual classmates. In fact, creating virtual classmates by mapping allows flexible generation of virtual classmates. For example, you can freely set the amount of the classmates. You can also control the functionality and the characteristics of virtual classmates to make them more consistent and better simulate. So here's an overview of our approach. Basically, we design two techniques. The first one is comment mapping, and the other one is motion mapping. For comment mapping, we cluster online learners based on the content type of their comments. Then we assign the comments of all learners in the same cluster to one virtual classmate. And for motion mapping, we add emotional reaction to virtual classmates based on a comments emotion. And there's more further details about the approach. So we applied an approach proposed by Song et al. In 2017. So basically, let's a naive Bayes classify. We classify these comments, each comment, into one of the 7 types, such as general conversation, notes, question, and opinions. And then we could represent each real learner by 7-dimensional vector based on the number of comments the learner left in each type of the comment. Finally, then we could apply the k-means cluster in this 7-dimensional seven-dimensional space, and then map all learners in the same cluster to the same virtual classmate. For motion mapping, we first do emotional analysis, which you can see here. We classify the violence and also arousal of the emotion of each comment. Then we map motion from a mocap database to this comment, which means that when we, if a comment will be presented by a virtual classmate, then we will look into the motion category of that comment and randomly select from a group of a similar emotional motion to make the behavior more realistic. So we use the MPI emotional body motion database. So here's a snapshot of the virtual classroom. And for the evaluation study, we use a course we got a 15-minute lecture video from an online course in Taiwan, and the topic is about the introduction to economics. And there are about 700 comments left by 50 learners. And in this study, we try to answer two research questions. The first one is, would virtual classroom with command mapping techniques influence the learning experience of learners? And the second one is, we wonder whether and how the number of virtual classrooms influence the learning experience of learners. And for the experiment design, so there are basically two factors. One is the number of classmates and whether the technique is applied or not. So there are 4 combinations of these factors, so there are 4 experimental conditions. Additionally, we set a baseline is a original time anchor commenting system, which is run on a non-VR platform. And we adopt a between subject design. So there are 20 participants for each condition, and there are totally 100 participants. So here's a quick view of the conditions. So I'm sorry that because these lecture videos are in Chinese, so I didn't translate it. But just try to give you a brief idea about things. So you can see here that the upper one is without command mapping, and the bottom one is with command mapping. And you can see that at your lower left bottom, those classmates taking notes, and on the right-hand side, the classmates they discuss, chat something that is unrelated to course. So, and here there's a comparison of the different number of classmates. And you can see that at the bottom, when there are more students, more classmates, you can see that the thing kind of maybe clotted. But we allow the participant to switch their or change their seat at any time during the experiment. And for the procedure and measurements, before the VR class, we ask each participant to take a pre-test. And then after the VR class, we ask the participant to take a post-test and also fill some questionnaire. And then we'll do interview. And there are 3 kind of measures in our study. The first one is learning outcome, which are the difference between pre-test and post-test. And we also designed a questionnaire including 14 questions in 5 Likert scale. Those questions are measured about social interaction and focus attention. So for the learning outcomes, we found that command mapping enhanced learning outcomes, especially in fewer virtual classmates. And for the social interactivity, surprisingly, command mapping could decrease social interactivity, especially in fewer classmates. And a possible cause for that is participants in C1 reduce the social interaction as they might focus more on classmates who mention course-related comments. And for focused attention, we found that in C3, which is 20 classmates and command mapping, was likely better than a non-VR condition. So here's a quick summary. For research question 1, we found that command mapping with 5 classmates is helpful for learners' learning outcome, but it may decrease learners' social interactivity. And for research question 2, we found that 20 classmates without command mapping enhance learners' social interactivity. And from this study, we would like to suggest 3 design implications. The first one is synthesizing virtual classmates with real learners' comments can influence the ways people learn in virtual environments. And for the second one, a VR classroom could make learners more concentrated and more willing to join the class. So these are we found from the interview. And the third one is the number of virtual classmates should be considered for learners' possible limitation in handling multi-party interaction in VR environment. So there are several limitations of this study. The first one is the interaction with users is still limited. We didn't allow users to leave comments because we didn't have a very convenient interface right now for the VR environment. So in the future, we'd like to add comment leaving function, and also maybe apply a chat bar technique to allow to answer participant or users' question promptly. And second one, we currently only explore very limited design space of virtual classrooms and VR classroom. Other mapping techniques such as filtering, manipulation, and questionization of the comment could be applied. And finally, the current study is conducted at a laboratory setting and very short-term learning. In the future, we might could conduct this study in the field and also do a longitudinal study. And for conclusion, we create the virtual classroom and the virtual classmates by synthesizing from real learners. And this technique maps real learners to virtual ones. And we mainly propose the two kinds of technique, comment mapping and motion mapping. I would like to say that these techniques are actually very simple. And so there could be many sophisticated ways to do this kind of mapping. And the idea can be applied to other domains. And you could just, for example, there are so many online social media, and there are so many comments which are time anchored, like live broadcasting events. And you could just collect these comments and map them to virtual characters. So in a way, this kind of idea, I think it could stimulate more research along this direction, because, for example, we may also combine avatar of real learners. They are online at the same time, and also virtual learners by our system, and even virtual learners played by chatbots. So in such kind of way, we think there are so many possibilities to explore this kind of technique. So the part of my talk, and thank you for your attention. Now I'll be happy to take any question. Thank you.
Hello, my name is Kojiro Yano from Osaka Institute of Technology. So you try to select motion of avatars from the emotion of the comments.
Right.
But from your slides, we seem to see the avatars from behind.
Right.
So we can only see the kind of back and hands and maybe the head of the avatars. So it seems to be difficult to get the emotion of the motion of avatars just by looking from behind.
Right.
So, but do you think that motion was really effective to convey the emotion of the avatars?
Okay. Thank you for the question. Actually, it's a very good question. Indeed, we tried to evaluate the effect of motion, but we found that the participants didn't feel much difference of that. And also, it's kind of a compromise between, you don't want to distract the learners too much because they are too exaggerate motion. But basically, we provide a freedom for the participant or the user because they can switch or change their seat at any time. So if they need that kind of the input, of course, we provide them. But if the participants want or the user want to just sit down and just to focus on the learning, and we could allow them to do so. But I agree that maybe in the future we could explore this kind of factor much more in the future. Yeah.
Thank you very much.
Thank you.
I have one further question. How complicated is it to set this kind of classroom setting up in a school scenario?
Actually, it's pretty simple because we just near AR, HMD classes device. I would say that it would not be too much different from the current online learning, but you just need to wear that HMD display. But I guess the only problem is the fatigue issue because you couldn't wear the glasses too long. Yeah. So that's probably the only consideration.
Can I ask a question? Sorry, I might have missed this. Is the purpose to make people feel less alone, or is it to motivate people towards learning outcomes? So what's the purpose of the application? For learning. What's the purpose of the application for learning? Is it to provide hints to the learner? Is it to make people feel less alone in a virtual space? Is it to motivate the learner, to provide motivation, or is it all? What's the purpose?
I see. So let me repeat your question to make sure I understand your question. So you're asking that what's the purpose of this learning, whether is the cross content or to provide a social interaction, right? Or did I get your question correctly?
But social connection in what way? For what purpose for learning? So how does the social connection bit fit with the learning bit?
I think this kind of interplay because if one of the problems of online learning is because there's a very high dropout rate. So if you couldn't attract the user first, then you are not going to teach them anything. So it's kind of, we need to find a balance between these two goals because I agree that social activity is not equal to the learning outcome. So these two could be, it's kind of we have to make some compromise between them.
To work out the connection between the two. Thank you.
Thank you.
Right. Next person should come up. So thank you again. So I have to say this was from Taiwan University and National Chiao Tung University.